Hello guys, this is Mr. Rego. So the idea is to rationalize this problem, rationalize the denominator of this problem. For that, I'm going to extend my whiteboard and then I'm going to explain what to do. So the idea is to get rid of that radical expression. I'm not allowed to have a radical on the denominator. So in order for me to get rid of this radical, what I need to do is I need to multiply my denominator times what is called the conjugate. The conjugate of this expression is the same two terms, but with a minus. So if this binomial is positive, so if I have a plus in between, then my conjugate will have a minus. If the original has a minus, then the conjugate will have a plus. Okay, same two terms, different sign, and the story. The denominator, if I multiply by this, I have to do the same thing on my numerator. Same exactly thing. Okay, keep in mind that the whole idea is to get rid of the radical in the denominator. Okay, so I'm multiplying. I got a binomial times a binomial. It doesn't matter if I have a radical. So what I have to do now is kind of FOIL, right? Or double distribute. So I'm going to take the first term times the first term, and that's going to give me 9. First term times negative square root of 11, and that's going to give me the 3 is on the outside. The square root of 11 is on the inside. Okay, and then I'll do the same process. And let's do with magenta with square root of 11. So square root of 11 times 3 is going to give me positive 3 square root of 11. And now square root of 11 times negative square root of 11, so positive times negative, is going to give me negative square root of 11 times square root of 11. You multiply the insides, 11 times 11 gives you square root of 121. Okay, and let me extend this line. All right, and now I'm going to do the top. So 13 times 3 gives you 39. 13 times negative square root of 11. Remember, the 13 does not have a radical. So technically, I will multiply the 13 times any whole number that is in front of the radical. If there's no number, you have a 1. So 13 times negative 1, it will give you negative 13, and I'll bring the radical of 11, square root of 11. Next. Now, the top, there's nothing that I can simplify, or I cannot combine those two terms. So I'm going to have 39 minus 13 square root of 11. The bottom, let's combine. I have a 9. There's no other whole numbers that I can combine, so I'll bring the 9. But let's look at this. Negative 3 square root of 11 plus 3 square root of 11. They're the same thing. One is positive, the other one is negative, so they simplify. They cancel each other, so they're gone. The last term is I have negative square root of 121. Can I solve this? Yeah, 121 is the perfect square. Square root of 121 is 11. Now let's keep going. The top stays the same. 39 minus 13 square root of 11. The bottom, 9 minus 11, negative 2. I have a negative in the denominator, not a good idea. So I'm going to bring that negative to the top. Okay, so I'm going to have a negative, and then I have 39 minus 13 square root of 11, and now the 2 is going to be positive. If I can reduce the 2 with those numbers, I do it. In this case, 39 is not divisible by 2, 13 is not divisible by 2. So let me affect those negatives. So I'm going to have a negative 39, okay, because this negative will affect this, and this negative will affect this negative. So negative times positive 39 will give you negative 39. Negative times negative becomes positive 13 square root of 11 over 2. And that will be my final answer. All right. Thank you for watching. Study that, please.